Welcome back to part 4 on polynomial functions and their graphs. Let's determine the end behavior of the following polynomials. Now that we've had some examples and we've talked about how you determine end behavior, we need to identify the leading term. In this case, it is 2x to the ninth. That means that our leading coefficient, 2, is greater than 0, which means it's positive. And we have a n that equals 9. 9 is an odd degree. So that means that our end behavior will be on opposite sides of the x-axis, and it will behave as our first example did, where we have end behavior in the bottom left quadrant and end behavior in the top right quadrant. We would say as x approaches positive infinity, p of x in this case, our polynomial p of x, approaches positive infinity. And as x approaches negative infinity, this part is along the left side of our sketch, p of x approaches negative infinity. Let's take a look at the next polynomial. Our leading term is negative x to the fifth. Negative 1 is the coefficient on that, and that is less than 0, so that is a negative leading coefficient. N is equal to 5, so it's odd degree. So in this case, we would say as x approaches positive infinity, q of x approaches negative infinity. And as x approaches negative infinity, q of x approaches positive infinity. Now let's look at s of x equals x to the sixth plus x to the third. Our leading term is x to the sixth. We have our leading coefficient of 1, which is greater than 0, so it's positive. Our degree is 6. So n equals 6, meaning it is an even degree polynomial. That gives me enough information to sketch the graph of the end behavior. If the leading coefficient is positive and the degree is even, the end behavior will be in the top left and top right quadrants. That gives me the ability to write my end behavior. As x approaches positive infinity, s of x approaches positive infinity. And as x approaches negative infinity, the function s of x approaches positive infinity. Let's look at our last example here. Our leading term in this polynomial is negative 5x to the fourth, and our highest exponent is 4. This means that my leading coefficient is negative 5. Negative 5 is less than 0, so it's negative. My leading term has an exponent of 4, so n equals 4, and the polynomial is an even degree polynomial. That gives me enough information to sketch my end behavior, which will be in the bottom left and bottom right quadrants. Notice I don't care what's happening in between the end behaviors. All I'm curious about is where the graph will end up at the end. As x approaches positive infinity, r of x approaches negative infinity. And as x approaches negative infinity, r of x also approaches negative infinity.